To present our next Drake Award, I am honored to share the screen with the legendary Jill Tarter. Let me tell you about Jill Tarter. In addition to co-founding the SETI Institute, Tarter led Project Phoenix, a SETI search for 750 star systems, and was a leader in the development and construction of the SETI Institute's 42-dish Allen telescope array. In addition to her scientific leadership, Tarter is a tireless advocate for science education for all students and for creating opportunities for girls and young women in STEM fields. Carl Sagan highlighted Tarter's work and career in his novel Contact, whose protagonist, Ellie Arroway, was loosely based on Tarter. Jodie Foster famously played the Arroway character in the 1997 film. Tarter continues to serve on the SETI Institute's Board of Trustees as well as its Science Advisory Board, and is Chair Emeritus for SETI Research at the SETI Institute. Her honors and awards are way too numerous to list, but just last week, Jill was elected American Academy of Arts and Sciences, a great and well-deserved honor. Hello, Jill.
Hello, Adam. Hello. I first met Dan a long time ago. Some of you know the story that I got into SETI by accident because in my first year of graduate school, I learned how to program a PDP-8/S computer in Octal. And I was a graduate student for a long time. That machine became surplus, and Stu Boyer, an X-ray astronomer, understood that with a radio telescope, you can make a noiseless copy of the output, and you can have a second data stream and do something else with it, like look for extraterrestrial intelligence. And so he came and recruited me. First thing I did was to create an acronym, the longest one I've ever created, Serendip, and I'm going to ask Dan if he remembers what it stands for. But I got this initial project started at Berkeley, Berkeley's radio telescope at Hack Creek. And then Stu did a really clever thing. He hired Dan Werthimer, who really got it started and made it sing. And that was the first Serendip system. And Dan blames us for the fact that he's not rich and famous, because he was part of the homebrew computer club early on with all of those guys who went out to become extremely famous. And Dan has been really generous over the years in terms of mentoring students and teaching them how to build radio astronomy instrumentation, SETI instrumentation, and doing it in a new way that the global community has adopted. He runs the Casper collaboration, and he was, of course, the chief scientist for SETI at Home, which was something that I think put citizen science on the map. But in Casper, he's figured out how to build large pieces of instrumentation by having blocks of instrumentation that can be put together in different ways. And so he's really changed the community and how we build our instrumentation. So Dan is totally deserving of this award. And he is, in addition to everything else, a sort of a peripatetic astronomy teacher. He's gone all over the world teaching classes to often underserved populations. And I think that if you have an intriguing spot somewhere in the world that could use a good teacher, you might consider inviting Dan, because he just might show up and your students would love it. So Dan, I would like to ceremonially pass the Drake Award to you. Congratulations.
Oh, so Jill, you are not only good at SETI, but you're also good at teleportation.
Yeah, we get all these skills.
Thank you, Jill. So I'd like to thank a few people and then talk a little bit about SETI. There's no one on this planet anyway that I'd rather share this award with than Paul. Paul and I have been working together for several decades, and it's been great fun. And by the way, that the Drake Award this thing goes really well with Paul's book. I don't know. So Paul's book is gold. It's a little hard to see, The Art of Electronics. And this award is perfect matching. It's excellent bedside reading. It's the kind of Bible of electronics. I want to thank Jill. She's, as you know, she launched the SETI program at Berkeley. She built the first instrument with her PDP-8 coding and a 100-channel autocorrelator, put it all together, brought it to Hat Creek Observatory, did the first SETI observations at Berkeley. And that was the pioneering work at SETI that attracted me to come to Berkeley. And that program that Jill launched, that has led to a lot of Berkeley SETI programs, big sky surveys at Arecibo and FAST, and the big one now is Breakthrough Listen, which is run by a student at Berkeley. I mean, he was a student in our SETI group, but now Dr. Andrew Simeon is running the Breakthrough Listen program in a spectacular way. It's got telescopes all over the world doing SETI. We're also doing optical SETI and SETI at home, Jill mentioned, and all that stuff came from this pioneering thing that Jill started at Berkeley. The person who really changed my life was Frank. And as Jill mentioned, I would have been rich if it weren't for Frank. I was in that homebrew computer club, and my computer was pretty good, maybe as good as the one Steve Wozniak and Steve Jobs were in that club, but I wasn't thinking about selling my computers. Because of Frank, I thought, oh, I should use these things to look for ET. So I'm not rich, but I am incredibly fortunate. I have a great job, and it's been really fun to work with Frank. We've been working together for a few decades now, mostly on optical SETI and more recently on pano SETI. And Frank is also my grand graduate student advisor. So he was a professor at Cornell, and Don Backer was a grad student of Frank. And then Don Backer became a professor at Berkeley, and I was a graduate student of Don. So I guess anyway, we're related. So it's a really honor to have an award in Frank's name. I also want to thank my Berkeley colleagues. There are too many to list, but there have been 100 students that have gone through the programs Jill mentioned. But I just want to name the 4 that I've worked with for decades: David Anderson, Jeff Cobb, Eric Korpela, and Matt Lebowski. These guys are the brains behind a lot of the SETI that we do there, the founders of SETI at home. I get a lot of the credit, but they're really the brains behind the operation. I want to thank Marilyn Alberts. So Marilyn and her husband, Watson, endowed the Albert SETI Chair at Berkeley, and that funded and launched a lot of projects that we mentioned and trained dozens of students, a lot of undergraduates in SETI. I may be a bit biased about her spectacular contribution to SETI, but because I'm the proud holder and the beneficiary of the Albert SETI Chair. So, and these people that I mentioned have not only been huge influences on my life, but I'm really fortunate to have them as my close friends. Finally, I want to thank my wife, Mary Kate. Mary Kate's a virologist testing COVID vaccines. She works in a lab wearing an astronaut suit, and she's testing how well the vaccines do against the variant. Pretty important stuff. And if she gets a Nobel Prize, I've agreed to take her last name. And she's agreed to take my name if I get the Nobel Prize. And if we both get it, we're going to swap names. Okay, those are the thank yous. I want to pick up on Paul's timeline theme, where Paul compressed Earth's history into a year. And I'm incredibly fortunate to live in that same millisecond as Paul and Frank and Carl and Jill and the other people I've mentioned. I want to thank my parents and their ancestors for that precise timing. So I'm alive in this great millisecond. But I want to go back, if I can share my screen, I want to go back a little further in time than Paul did. So I want to go back 4 milliseconds in time. I think Paul went back 2 milliseconds in time. And this is stuff that Frank taught me. He taught me about the early history of SETI. So Gauss 200 years ago, said that in order to get in touch with ET, we should make large geometric structures on the Earth, a big right triangle of pine trees and big squares of dirt, water, and wheat. And ET would look down and see we knew about the Pythagorean theorem. On Paul's timescale, 3.6 milliseconds, thousandth of a second before midnight, von Littron suggested that we get in touch with ET by digging a circular ditch 20 miles across and fill it with kerosene and use this match, not to scale, to make a bright ring of fire, and ET would see this bright circle of light and get in touch. And Charles Crow, about 3 milliseconds ago, suggested that we get in touch with the Martians by using large mirrors to reflect the sunlight to the Martians. One where he lived, other mirrors to outline the shape of the Big Dipper, and ET would see these bright lights on Earth and get in touch. And these are funny to us now, but I think Frank didn't mean them just to be entertaining and humorous. I think he was trying to teach us humility and modesty. These were the best ideas of the time. And so that means that 200 years from now, maybe people will be laughing at what Paul and I and others at the SETI Institute are doing. And maybe the SETI Institute will have to withdraw these great Drake Awards in a couple hundred years. Okay, I want to talk a little bit about things that we and others are working on about the future of SETI. One of the things we're just starting to get going, the Arecibo telescope in Puerto Rico unfortunately collapsed in December. And so we're starting up these big sky surveys at the telescope in China called FAST. It's even bigger than Arecibo, it's 500 meters. And we're just getting going now, doing a big sky survey. It's going to take several years to complete that sky survey together with our Chinese colleagues. Another thing that I think is going to be really exciting, this doesn't exist yet. This is an artist thing. It's called the Square Kilometer Array. It's made of thousands of dishes. You might notice that it's has the same philosophy and architecture as the Allen telescope, which was the pioneering way to build a big telescope out of lots of little telescopes. This will be even more. Right now, there are 64 of these dishes, not this many, in South Africa. And the Breakthrough Listen team is starting to do a big SETI project on this prototype for the Square Kilometer Array, but already it's a spectacular telescope in South Africa. One of the things that I've been working on with Paul and with Franklin Antonio and also Shelley Wright and colleagues at UC San Diego is a project called PanoSETI. And what we're trying to do here is look for flashes of light, maybe a billionth of a second long, bright flashes like a lighthouse. And the problem with looking for flashes is we don't know where they're going to go off. We don't know where ET is looking. And what we've been doing so far has a big problem that we look at just one little place in the sky at a time. So we might be looking over there and the flash is going off on the other side of the sky. The telescopes that we use now just look at a little tiny part of the sky. It's like looking through a soda straw that's 30 feet long. It looks at a millionth of the sky. And so it would be so easy to miss these flashes if they're going off once a day or once a week or once a month. So what we want to do is build a telescope that can look over the whole sky at the time. We'll have a few domes with maybe 100 different telescopes poking out in different directions. And we don't, by the way, that was an artist's conception. You can tell by that woman standing there. She's not really standing. I think she's kind of elevated off the grass. We don't have that yet, but we do have is a couple of prototypes, 2 telescopes working at Lick Observatory, which is not far from the SETI Institute in Berkeley. We've been doing a lot of SETI experiments there with Frank Drake, and this is our prototype for the PanoSETI experiment, which is working well. So we're getting ready to build the big thing. I'm optimistic about this experiment. I'm excited because we're exploring a whole new parameter space that nobody's really looked at before, these kind of billionth of a second or millionth of a second timescales. And in astronomy, it's kind of bizarre, but when you look at some place new that nobody's not looked at before, if you look at a bigger scale on the sky for larger objects or little tiny things, or if you look at a new wavelength or a new part of the spectrum, or in this case, looking at a new time scale, there's usually phenomena to be discovered. We don't understand why, but nature populates all these different scales with phenomena. And so a lot of astronomy discoveries are made by just looking at some place that nobody's looked at before. So we might find some new phenomena. If we're really lucky, we'll find a flash from ET. Well, I'm optimistic in the long run because of the technology is growing so fast. This is radio telescope improvement, doubling every 3.5 years. Computing power, as you know, growing exponentially. So I'm optimistic that I think right now we're just getting in the game. Earthlings are learning how we might communicate with ET, but in the long run, we'll be able to do thorough searches. And maybe in 1,000 years, we can make the sun into a giant telescope. You can use the sun as a gravitational lens. Einstein showed that big, heavy things bend light. This is not easy to do. This is why it's a ways off, but you have to place the camera way out beyond Pluto. But if you could do that, you can get 10 meter resolution on an extrasolar planet. So you could see buildings like the SETI Institute on an extrasolar planet. Finally, I wanted to end up with some haikus written by the SETI at Home participants. The SETI at Home participants have helped us in a lot of different ways. So a big thing is, of course, they made one of the biggest supercomputers on the planet and the most sensitive search ever done. We're really grateful to the SETI at Home participants. Another big contribution they do is that they help us write the code. It's a big open source software, and they got it working on all kinds of different computers, and they get the bugs out and add new features and make it go faster. And they also compose music and literature, and a lot of people have composed poems, including haikus. I just want to read you a couple of haikus from the SETI at Home participants. Dan Seidner, 1 million Earthlings bounded by optimism leave their PCs on. And this is the last slide, another haiku by Paula Cook. Searching for life, answers are revealed about ourselves. Thanks so much.